Hello everyone, how's everybody doing? Hope you're doing fine. We're gonna have a little interesting geometry class today, but I'd like to start with the questions. Had questions about extinction and about another subject which is at the root of physics, which is what is an object? Okay, so let's start with these comments here. First one has to do with extinction. And the fellow says, there are lost tribes that have had little to no contact with humanity. They don't live in cities and are not subject to economic collapse and thus starvation. Let's grant your theory of economic collapse and worldwide starvation. These humans will survive because they are not affected by your mechanism of extinction, as they are isolated, not in cities, and live as hunter-gatherers or agricultural existence. Thus, humanity survives and eventually, 100, 1,000 years later, will repopulate the earth. I mentioned this comment because lots of people have, over the years, mentioned this thing. So they say, what about those lost tribes? And okay, so let's go on with my answer here. I synthesized them. Okay, first of all, the tribes are not lost. There are no such things as lost tribes. The satellites have located everything on Earth. You can see a matchbox from the satellites, okay? So every bit of land on Earth has been already scouted, so to speak. And then some tribes, they're just made of, most of these so-called lost tribes are really known as uncontacted tribes. We know they're there, but we just haven't contacted them, or they refuse contact or whatever, or we don't want to bother them, that sort of thing, okay? Some of them are just composed of a few families. In one case, I'm going to show in a minute, there's only 4 families forming the so-called tribe. And most of them, in fact, none of them are above 1,000 in population, and most of those populations have already had contact. We'll call it with a white man, with a civilized man, right? People who are truly living in the jungles, all on their own, not trolled by us, very, very few on the planet, okay? And that's why, because of that third point, because we cover their defense budget. We protect them. It's they are not bothered even by tourists, because we don't let the tourists go over there. Otherwise, lots of people would go in that area, especially loggers who want to get rid of some of these Indians, or whatever you want to call it, natives. And they these natives are in the way. They're in the way of progress, right? And then there's the issue of loss of genetic diversity, which I'll talk at the end. But let's look at some of these things. Here's a group of people that, a few tribes that I looked up this reference that this person gave me. I pulled these out of there, okay, just to give you an idea what we mean by these uncontacted tribes. Who are these people, And here's a couple of them. One is the Ayoreo. There's supposedly 5,600. Most of them, right, are already in civilization, of these 5,600 when you look them up. But it says traditionally nomadic hunter-gatherers, right? That's tradition, right? The majority of the population was sedentarized by missionaries in the 20th century. Okay, so a lot of these people, they're no longer uncontacted. And for sure, most of them don't live in the jungles. The few remaining uncontacted Ayoroko are threatened by deforestation and loss of territory. Again, we have to give them protection, because otherwise, between tourists and loggers and who knows who wants their land, they'll take over. So the government said, look, these are natives, and we want free determination of these people, so we don't want anyone bothering them. So the government protects them. Okay, you have the Yuki in Bolivia, composed of 4 families. Oh man, big tribe. They have intermittent contact with the Christianized Yuki. Okay, so there's the uncontacted and the contacted. and most of them are contacted, and they're Christians, probably missionaries went there and civilized them, gave them guns, that kind of thing, sex, triple X movies. The other one, hi Marima. Okay, their area has recently been declared protected. You need protection. Okay, otherwise, someone's going to go in there and what? They can even kill them for all we know, and so you got to keep that in mind. And then you have the Wayampi in French Guyana, and there's another Guyana there that has the same situation as this one. Practice slash and burn agriculture. If they're practicing agriculture, that means they're not hunter-gatherers. That means they're not in the forests, in the jungles, okay? We're talking about something else when we're talking about agriculture. We're talking about a much more advanced man than the basal hunter-gatherer. Talking about maybe upper Paleolithic, 40, 50,000 years ago, we're talking about something else here. We're talking about people who have agriculture, okay? And they subsist on what? On, all those things, sweet potatoes, yams, bananas, okay? Those, they grow, okay? And says the Mariri community carries out limited exploitation of gold claims. Now that's hunter-gathering, I guess trade and hunter-gathering. The Wayampis that work as civil servants in the local administration are paid through gifts. Okay, so yeah, a lot of these are put in there for padding in the article, like saying, oh, we have all these tribes that have not been contacted. No, they're put in there for padding. 90% of them. There's very, very few people who have no contact, and those people are protected because someone's going to kill them. And it turns out that, if the world collapses, okay, and goes to hell, the whole global economy, first thing anyone near there is going to do is going to go in there and kill them and cannibalize them or whatever. They're going to, and if they don't do that, they're going to hunt whatever these people hunted. And so these people will be marginalized from their source of food anyways. So to think that these hunter-gatherers are going to survive the collapse of a global economy because they're not in touch with us, it just shows that these people are not thinking. They don't have their thinking caps on, okay? Here's one group of people that became famous recently, and they're known as the North Sentinel Island. It's there in the middle of nowhere, okay? And it's an island belongs to India, and these people are protected. Turns out that missionary went there. I think he was a young guy, about 26 years old, and these guys killed him, and that's why they were in the news. And there's a lot of fishermen in those regions. They want to go to this island to fish and so on, and the government won't let them. In other words, these tribes are protected, okay? And these are one of the things you got to keep in mind. The first people who are going to go in the States are going to be the Amish. Why? Because they're not protected right now. We're paying for their protection, okay? And they're protected by the courts, and they're protected by military style, police, etc. Tomorrow, that's gone. There's no protection. And if these guys don't even have a radio to know what's going on out there, they're going to be swamped by all kinds of people who are starving. They're just going to overrun their farms, eat them as well. So this notion that the uncontacted or people who grow their own stuff and do not participate in the world economy are going to survive, those are the first people who are going to go. It's the other way around, okay? We're going to slaughter them first for sure because they have no protection at that point. Okay, this is, I went to Brazil, you can see with my family some time ago, and I went to see the Ticuna. And on the right, you'll see an old picture of the Ticunas. On the left, you'll see, my party over there. And you can see some of the ladies, they have no bras. They're in their natural state. And it turns out that when we went on the boat, on this little boat that we went there, I think it was like half an hour to 1 hour ride, something like that. And the Indians over there, the natives, they got a word that tourists were coming. And so the gals took off their blouses and their bras. That's what they did. before we came, painted their faces, that kind of thing, to put on a show. And you can tell because, have these huts which are standing above the level of water with poles, because water rises every now and then. So the river rises, the Amazon River. And so they have these huts up there. But what you'll see is an antenna coming out of their houses. They all have TV in there, and the girls, guys and girls, they go to the city and during the day and they go to school. They have to travel in any way they can, usually by boat, to the cities to get an education. Some of the girls, they're prostitutes. They work the night shift. And so to think that, and these people, these tikuna, they're in touch with those uncontacted tribes. And these people are smarter than those, and they'll for sure liquidate anyone who's out there who's unknown, uncontacted. So this notion that, these people will survive is just incredible. And here's proof. You want proof? We'll give you proof, okay? Here we have 4 different types of societies, okay? And what you see here is on the upper left, these are Bedouins, okay? And they go around with their camels and so on. And you can see they've got dresses that they probably wouldn't manufacture out there in the middle of the desert. No, they trade. They trade, and therefore they're in contact, even though they're nomads and they don't really participate in general with the global economy. They do trade, and they're in contact with our economy. So they do depend in many ways on us. And by us, I mean the civilized world. These are considered people who are not so civilized, even though they are quite civilized, I think. It's just their way of life. On the bottom right, you'll see the same thing in Afghanistan. You'll see their dresses. Where they get those dresses. They get them up there in the mountains. On the upper right, you'll see the pygmies. And you can see the kids are wearing shirts. And I think they don't make them in that hut behind them. I think they make those shirts somewhere else. Okay, so even the pygmies are in contact with civilization. And then on the bottom left, you see what I'm talking about. These are from New Guinea, Papua New Guinea. And, they have scores to settle with rival tribes. And what these people do is they trade with the white man, with the civilized man, right? They trade their bows and arrows or whatever they trade, I don't know, for guns. Because they have scores to settle with tribes. And there are tribes within New Guinea which are uncontacted. But these people know where they are, and they're going to hunt them down. Again, this notion that someone will survive out there because he's not in contact with our civilization or with our economics is absolute nonsense. It means these people, again, are not thinking. And here's more proof. If you want proof, here's the famous case of Maoris in New Zealand that wiped out, or more or less almost wiped out, the Moriori. It says the invaders, this an article in the Wikipedia, but I've had it for a long time. It says the invaders, Maori, right, killed a 12-year-old girl and hung her flesh on posts. Talk about civilized people, right? They're in contact with civilization. They proceeded to enslave some Moriori and kill and cannibalize others. With the arrival of a second group, parties of warriors armed with muskets, clubs, and tomahawks, led by their chiefs, walked through the Moriori tribal territories and settlements without warning, permission, or greeting. If the districts were wanted by the invaders, they curtly informed the inhabitants that their land had been taken and the Moriori living there were now their vassals. Okay? And a Moriori survivor recalled, the Maori commenced to kill us like sheep. Only 101 Moriori out of a population of about 2,000 were left alive by 1862. So you want to know what happens to long-lost tribes? First, they're not long lost. We found them all. Second, they're uncontacted, meaning that we're protecting them. That's why they're not uncontacted. We know where they are. And third, when that protection is gone, they're going to be the first ones to be gone. Okay. So now this notion that someone's going to survive because they're not in contact with our economic system is absolutely nonsense. Okay, here's another one, I think from the same fellow, and he says, says a more likely scenario inspired by the French Revolution. In this scenario, we are again at the precipice of economic collapse. Okay, and he goes through these steps. He says large companies start producing food, economic collapse. People revolt, government either overthrown or decides to act in people's favor and takes over the big corporations' assets. Government starts producing food for the people, and people survive. What's wrong with all this? Well, what's wrong with this is, again, people mistake the manufacturing and agricultural age of the French Revolution. Even you can take that as far as the Russian Revolution of 1917. That's different than what we have today. We have a new world today. Just in case you haven't noticed, there are no countries today. Okay, there are no countries today. We have what is called globalization. That means the corporations are multinationals. Okay, and so now we have a global economy, or we're working towards that. We haven't perfected it yet, but that's where man's artificial economy is going towards. We're making a one world government, so to speak, in terms of economics. Okay, so when it collapses, in all these cases, there was always some country was doing good and another one's doing bad. And the ones that were doing bad, the politicians managed to get resources from another place to fill the holes, so to speak. But when the global economy collapses, the Martians are not going to come here and help us. Okay, they live too far away. Okay, so no, it's a totally different situation with a collapse happening today. And by the way, when I say collapse, I mean money will be no more. See, these people still had money. And so that's not the same situation either from that point of view. Okay, so there's many things wrong. The other issue this guy mentioned is that, I made false predictions. I said some time ago that we would be gone, extinction of man, maybe in a few years, months or years. And yeah, you have to distinguish the theory from the prediction. Prediction is religion. That's my religion. I have my beliefs, and I'm a lousy astrologer. I've admitted that many times. You don't have to look at my predictions. That's my sense of what's going on, but that has nothing to do with the mechanism that I'm explaining. When I'm talking, it's raising a straw man by saying, oh, Bill's prediction failed, so his theory is wrong. No, the theory has nothing to do with the prediction. Okay, those are two different things. You want to attack, you attack the mechanism, because that's what's the part of science. The other one's part of religion, my personal beliefs. To raise the issue and say, hey, Bill, your prediction came out wrong. Yeah, I know. I lost at the horses too, by the way. I bet on that horse. I knew it was going to win, but he didn't win. And so does that mean my theory is incorrect? I mean, what does one thing have to do with the other? So yeah, we got problems with a lot of that stuff. Anyways, here's another comment, and this one brings up the issue of shape. He says, shape is not form. This is a second or third individual that mentions this. So I want to clarify this because the word object is crucial in physics. So I'm going to fight that till the end of the earth. Okay, we need to defend the definition of object no matter what. And so shape is not form. We observe shape in space, not form. That which has form is an object. Okay, and Matthew uses shape, not form. Okay, so what are my replies to that? Got a little synthesis here. Hope I get the right one. Ordinary speech, that's what he's talking about, okay? In ordinary speech, we say shape and form are two different things. And you can say that in ordinary speech, shape refers to 2D, whereas form refers to 3D objects out there in space. In physics, shape and form are synonyms. We can't make a distinction because we only have on and off, yes or no, black or white. It's got to be just two opposites. There's no maybe. There's no gray. Okay, so you have to define the word object, and we define it as that which has shape. You want to use the word form, same thing. That which is shape or form. It doesn't matter. It has to have some kind of outline, some kind of perimeter, some surface, if applicable. Okay, but it has to have just an outline. That's it. If there is an outline, it has shape or form, whatever you want to call it. It doesn't matter, and it is an object by definition. Otherwise, the person who wants to go through all this stuff, gets into these little rabbit holes. Is a cube, a perfect ideal cube? Does that have shape or form? Because we can only see an ideal cube on a 2D surface. Okay, and so the question is, are we going to say that's got shape, or are we going to say it's got form because it's 3D? And we get all these rabbit holes. We're trying to find out, what the definition of the word object is. And these people say, well, we have all kinds of objects. We have 2D objects, and we have 3D objects, and maybe we even have 4D objects like, tesseracts or space-times or whatever. We can't get into all that nonsense because, first of all, in physics, we do not have adjectives next to a noun, an object. There is no such thing as a black cat in physics. There's only a thing as a cat. Okay, there's no black cat, no white cat, no yellow cat. Okay, and to say, well, this is a shape object and this is a form object. No such thing. There's only an object. You got to define the word object. And so the issue here is the proponent of shape not equal form must define object unambiguously and rationally to be used consistently, scientifically, right, in physics. That's the homework, right? So you can't just come in here and say, well, I don't like the word form or the word shape to be used as a definition of object. Then just define the word object and we'll know. We'll know what to use. And it's got to be used consistently, and you can't go through all these little rabbit holes and say, well, these are these kinds of objects, because then you get into what the mathematicians have. They have mathematical objects. And we'll get to that a little bit today, maybe. Okay, here's another comment. Last one. Okay, and it's got to do with the subject matter of today. It's got to do with location. Seems to me a point is just a location relative to the object it's associated with or helping to define. It doesn't matter what the point actually looks like. I thought we were doing geometry. I mean, does it matter what a square looks like? Does it matter what a cube looks like, or a sphere, a pyramid? These so-called objects that are used in geometry. It doesn't matter what they look like. I can get a cube that looks like a sphere. Doesn't matter what it looks like. Hopefully it does, because if it's got to do with geometry, it better start at looking like, at shape. That's what geometry is first and foremost, about shape. So it does matter. But then here's the issues, again, outlined, okay? Put them over here. Not so that you can see my face, but so that I can see them. Okay, why use the word point? I mean, if it's a location, as you say, that's very simple. Why don't you use the word location? That was the issue. And why not just say, location? Why represent it pictorially to begin with a dot? Why do you put a dot there if you're going to say, well, it's a location? Do we use objects to represent concepts? Are we using shamanism? Is that what physics is about? What geometry is about? We're going to represent anger with leopard. How's that for shamanism? Or we're going to say that the heart represents love. Does that make sense in physics, or is that poetry? And so this is the issue, why did they put a dot if they're going to say location? Why did they call it point? Just use the word location. Say, hey, this line has so many locations, and between any two locations we can find infinite number of locations. You can say all that. Why use the word point? Why use a represented with a dot and confuse everybody and say, well, you can put a billion dots between two dots? Well, I don't think so. Depends on the dot size. If you have two dots and each one is 1 centimeter wide or diameter, right? You can't fit a gazillion, and they're just 10 centimeters apart. You cannot fit a gazillion dots of that size between those two dots. So no, you cannot make that statement once you talk about objects. You can only make that statement if you're talking about locations. But then why use the word point and confuse everybody and say this is a dot, but this is what it means. Or this is what I'm going to use, okay? Does the dot move? I mean, does a location move? You know, I mean, we can move the dot. Can you move a location? Okay? Order is an ordered pair of dot. Okay, we have X and Y, right? Or is that how to get to the treasure chest? You know, the pirate walks 10 feet to the right and, I don't know, 20 feet north, and he finds the treasure chest. Is that 10, 20? Is that a dot? Or are those the instructions on how to find the treasure chest? We got all these problems with all of what the mathematicians have created here, because it all contradicts, one thing contradicts the other. Okay, is an ordered pair of time interval? Is it a location or motion? I mean, you know, what is X, Y? X, Y are instructions on how to get to the treasure chest, right? And, you know, they have this notion called position in mathematics and geometry. And what are we talking about? We're talking about this guy moving 10 feet to the right, 20 north, right? And we say, so we're talking about motion. We're talking about how to get there. We're not talking about location or position for that matter. We're talking about motion. We're saying this is what you got to work. You will have to walk 30 steps to reach the treasure chest. That's what you're saying. Okay. And then ultimately, if it's location, what does it have to do with geometry? You know, geometry is a study of shapes. First and foremost, I mean, you know, of course, you're going to do relations, etc., of angles. But then what does location have to do with geometry? The dot, yeah, that's a figure. You know, if you have a circle or you have a square and you represent that, the dot, you know, that is your representation of what you call point. Well, that's a 2D figure. So that's a figure that belongs to geometry, but it's 2D because what I'm staring at objectively in front of me is 2D. That's why it's 2D. And you say, well, you're not supposed to look at the picture. Oh, okay, what am I supposed to look at? Well, you're supposed to imagine, close your eyes, and imagine what it represents. Oh, what does it represent? It represents location. Why did you say that to the beginning? Why didn't you just say location? What is this nonsense about point? Okay, no wonder they can't define it after, what, 2,000 years, 2,500 years since the Greeks. Nobody can define the word point because they have these different concepts merged into this notion of point. That's why they can't define it, and they never will, of course. Okay, so let's go back to where we were the other day. We started off with Mr. Euclid, and Euclid said the following. He said in his book, right, a point is that which has no part, whatever that means, right? And he continues in definition 3, he says, the ends of lines are points. Okay, so what is the issue? The first issue is that Euclid was like a Harvard graduate today. You know, he's got a worthless degree because all he's done is just memorize stuff created by others, okay? I mean, the only reason people go to Harvard or Cambridge today is to get jobs, to get contacts, the right contacts. That's why they go there. They don't go there to create new knowledge, new theories or anything like that, because they're all mommy's boys. They're people who someone paid their tuition and their schooling. They go there, or they have money, or they have references or whatever, and they go there to have good contacts, to make contacts, right, for their future careers. That's got nothing to do with science. That's got to do with politics and religion. And Euclid was, you know, a Harvard graduate. He was a Cambridge graduate. He was just a guy who was rich, who studied. And what did he study? He studied what everybody else had already created. So he's just a student in this sense. And we remember him and glorify him only because he's the guy who wrote the book on geometry, right? But every concept in there, you know, came from before him. He was in the 3rd century BC, and you got people like Aristotle, who was in the 4th. You got people like Pythagoras, he was in the 6th. So, you know, a lot of people preceded him by decades and by centuries. And they had already developed. I mean, you know, the pyramids in Egypt, they were built 3,000 years before Christ. And so that guy must have known a little bit about geometry and a little bit about mathematics to build that thing, okay, a little bit. And so, you know, a lot of these concepts have been around for a long time, and all Euclid did was kind of put them together. And one of the guys he certainly got this from is this man, you know, Aristotle. Aristotle, he wrote several books, or at least he's credited with writing these books. That's not completely settled, but it seems that that's the case, okay? But Aristotle says in his book called Physics, okay, book 6 here, the extremities of 2 points can neither be one, okay? And what is he referring to? He says, look, if you have a dot that's made, like I like to state it, made of a single piece, okay? If it's made of a single piece, that means it's not made of parts, okay? So that's my notion of what single piece is my notion of continuity. Okay, that's what he's addressing here. He's addressing continuity. And he says the extremities of 2 points can neither be one, right? Because if you get two, you know, you can't make them into one. That's what he's saying. And second, he's saying those dots supposedly have no extremities. I put them in green there just to point out what he's kind of referring to. He's saying they have no extremities because they're made of a single piece, and he calls that indivisible. Okay? And where does he get this from? He gets this from Democritus and Leucippus, who was Democritus' teacher, apparently. Okay, that's not settled either, because these guys, we have no writings from these people. We only know them through the writings of people like Aristotle. And what did they invent? Well, they invented the atom, or this is what they vouched for. Whether they were the creators of this, also we don't know. But Democritus talked about indivisibles, and that's what the atom is, and that's what the point is, okay? That which has no part, well, you'll see it at the bottom. That comes from Aristotle, at least. That's one of the sources Euclid certainly used. And he says, the extremities of 2 points can neither be one nor together. Why? Because since that which has no parts, right? This is Aristotle, right? Can have no extremity, okay? And the extremity in the thing of which it is the extremity being distinct, okay? So in other words, what are we talking about here? We're saying that if those dots, those 2 dots at the top, are made of, each one is made of a single piece, Aristotle says you cannot make something continuous with them. You cannot make them because they have no ends. They have no extremity. Okay, it's made of a single piece. And so this is my term, by the way. Okay, so indivisible for me just means made of a single piece. I like to use that because it's more related to physics. Okay, and so here you have a single piece, line, box, whatever you want to call it, at the bottom. Okay, and it's got no extremities because there is no point at that extremity. The only way you can get it, the points there is if you divide the box up, chop it up into pieces. But then Aristotle is saying that the components of that also have to be subdividable. They have to be divisible. Okay? And what is he referring to? He's referring to, again, he's trying to address Democritus's atom, is indivisible. So, you know, they're clashing in their philosophy and their notion of what they mean by continuity and what they mean by discreteness, because that's the fight here. The fight is between discrete and continuous. That's what it is. Whether something which is continuous can be made of a single piece or it is segmented. And well, he's got the opposite notion of what I have, exactly the opposite, because my notion is that an object is continuous if it's made of a single piece. And if it's chopped up, it's segmented or made of discrete parts. And Aristotle's notion is that only if it's made of discrete parts which themselves are chopped up into segments, only can then something be continuous. Well, why did he say this? Well, he's addressing 2 other issues. He's addressing motion and he's addressing time, neither of which really has anything to do with geometry. But this is what the Greeks did. They mixed all these concepts completely, you know, they bundled them up into a single notion of line and point. every time they talk about the point, they talk about the line because they're going to be talking about continuity. And why are they talking about that? Because they're going to be talking about distance. They're going to talk a length, which even today they consider distance and length synonyms. Why? Because you measure both of them, so it doesn't matter if you're measuring a table or the distance between two tables. It doesn't matter to a mathematician because he's just looking at his measuring tape. And Aristotle is also talking about motion, which is more or less distance traveled. In that sense, it's the same thing as distance. And they're talking about time. And the question is whether all these concepts are chopped up into segments, into little pieces, into little dots, into little locations, points, whatever you want to call them, or it's made of a single piece, meaning continuous, according to me, Okay, but let's continue. So here's Aaron, and he comes up with this other notion, or this is really a summary, really. Geometry, a no-part point, okay, that's at least Aristotle's notion, and I'm sure Euclid got it from him. To at least to a great degree, he studied what Aristotle wrote. Indivisible, he gets that from Leucippus and Democritus. They're atom. Atom means indivisible. That's why, we have that word today, the indivisible, the atom, right? Which turns out was divisible. And the concept of continuous, that's where they're going to be applying the word point, which means so many things: location, number, ordered pair. It means so many things. And we have to be careful because they keep switching from one context to another. But the notion of continuous has to do with both the notion of motion and the notion of time. Okay, so this is when they arise with the geometric notion of line. What is a line? A line is geometry, or are we going to talk about motion, displacement, distance, time? What are we talking about here? And this is the issue. They're going to be confusing all these in a bundle. And so he says, these are words directly from his book, that which is continuous is composed of points. Nothing that is continuous can be composed of indivisibles. Okay, that means he's suggesting that the point has to be divisible if it wants to form something continuous, such as a line. Okay, that's an important point that he's trying to make. And the last one, a line cannot be composed of points. I'm sure a lot of mathematicians wouldn't like that to read that today. The line being continuous and the point indivisible. So he's saying the point has to be indivisible. So how did they arrive then at this no part point? They're saying that the point is made of no parts. So we have two schools of thought here, kind of. On the one hand, we have the point, which should be divisible according to Aristotle if it wants to form part of a continuous line, because he's saying that one comes right after another. So he's talking about succession of points, and that's his notion of continuity. And the other guy who says the point is the ultimate thing, the indivisible, it is not made of parts. So that's what they're referring to. When they say it's not made of parts, they're not really saying zero-dimensional, as the notion has, been bequeathed, or how we inherited it today. Okay, we inherited the notion that you have planes, they're two-dimensional, the line is one-dimensional. What's the point? Well, it's zero-dimensional. That's not what Euclid or the Greeks in general were referring to. When they're saying the point has no part, meaning it's not made of parts. Okay, that's what, and these were the two schools of thought. One guy said it's not made of parts because you have to have something that makes up everything else, and the other guy says, well, we got a problem because if we're going to explain time and we're going to explain motion, we need to have all these chopped up into locations. Now we introduce location in, and a location can be chopped up into pieces as well, to more parts, right? And so if we're going to use the point, the geometric point, to represent a location, the point had better be able to be chopped up into pieces as well. So they had these philosophical, notions that they were discussing, debating, and disagreeing on. Okay. Okay, so this is the issue. The issue is that Mr. Aristotle is going to extrapolate these things to things that have nothing to do with geometry, even though he's talking about physics there, as you can see in his book. He's talking about all kinds of stuff that he mixes in there. He says, nor can a point be in succession to a point or a moment to a moment in such a way that length can be composed of points. Now, if you talk about mixing irreconcilable notions, he's talking about locations being mixed with seconds, moment to moment, right? Length, which I guess it's meters or centimeters or millimeters. I don't know what he was using, but we've got a whole bunch of notions here put into this word point. So he says, how can a point be in succession to a point? Meaning, I guess he's referring there to the geometric point, the dot next to a dot. That's what you're supposed to visualize. But then he immediately changes to moment, which you can imagine as second following second. And then the other guy, length, maybe a centimeter following a centimeter. What are we doing? What is he doing here? What is he trying to do with all this mixture? And he continues, that which is intermediate between points is always a line. So we have, a line separates 2 points. Is he referring to a line? No, he's referring to distance, but he calls that a line or designates it as a line or represents it with the geometric line. That's how we get our one-dimensional line. The distance between 2 points is a straight line, right? That's the definition of line today, shortest distance between 2 points. So we're saying that a line is a distance, okay? And that which is intermediate between moments is always a period of time. Now he talks about an interval. Okay, so we got all these notions mixed into this word point, which cannot be defined or you cannot talk about it really much unless you bring in the line. Okay, you got to bring in the line. But neither the point nor the line are referring to the geometric figures known as dot and line. They're referring to distance, to displacement, to intervals. They're referring to something else. Because that's where they're going to use them. And it says, if length and time could be composed of indivisibles, right? They could be divided into indivisibles. And yeah, that's the notion, as you see at the bottom, of the chronon that we have as far as time is concerned. A proposed quantum of time, that is, a discrete and indivisible unit of time as part of a hypothesis that proposes that time is not continuous. And again, they're using the notion today is that continuous is the opposite of what Aristotle said. His notion was that continuous is a bunch of discretes lined up. So you can see what's happening here, and this is where we start. Remember, this is where we started out with geometry, and we built upon this, and that's where mathematical physics stands upon. This quicksand made by all these Greeks, especially, I guess, Aristotle, which, again, probably took notions that he inherited from his teachers, passed it down, and Euclid got it from him, and so on down the line. We got it from Euclid, and so we've got it all the way to today. Nobody challenges this. It's like nobody challenged any of the nonsense that these people put down because they were mixing all these concepts, one with another one. Okay, so these are the conclusions to which Mr. Ari arrives, and I try to illustrate it there. It says, no continuous thing is divisible into things without parts. Okay? So it's got to have parts. Otherwise, you're not talking about continuity. Infinitely divisible is continuous. Okay? Continuous means infinitely divisible. That's his conclusion. Okay? And everything continuous is divisible into divisibles that are infinitely divisible. If it's indivisible, then you don't have a continuous whatever. Line, plane, solid, whatever. But then the next point says the extremities of things that are continuous with one another are one and are in contact. So here you have two lines made of points, I guess, but it's continuous because the line, is chopped up into points. So far we're continuous. We don't know what each point does, but at least so far we have continuity according to Aristotle. But he says that they must be in contact with each other, okay? To make that whole thing say, okay, now we have something that is continuous. Okay? And as you can see, his corollary there applies equally to magnitude, to time, and to motion. So again, what does time have to do with geometry? I have no idea. But this is the problem that we're going to start out with. Remember, this is the dawn of civilization. And this is, in the West, we're going to inherit all this from Aristotle. Went through the Arabs, right? But it ended up back in the West. And these are the notions we're going to build mathematical physics upon. Okay, so now we have a few years later, like 1200, well, a little more, in the 13th century, we have Mr. St. Thomas Aquinas, an Italian, who traveled a little bit around Europe, and he studied a lot, and he was a religious individual. Okay? And he's going to take all these notions from Aristotle and from another fellow known as Boethius. And Boethius was a 5th, 6th century individual who was a right-hand man of Theodoric the Great, one of the mafia guys of those days. They call them Caesars, kings, and whatever. I call them mafia guys. And Theodoric put him in prison because he suspected that Boethius was plotting against him to overthrow him. So he put him in prison for about a year, then executed him. But before Boethius was executed, he had a lot of time to think in prison. It happens to a lot of us. And so he thought aloud, he thunk, and he came up with ideas because he was a very learned guy. He knew like 5 languages, among them Greek. And so he took Aristotle's work and he tried to do something with it. He tried to apply it. And he applied it to free will versus determinism, trying to figure out that. And also to time and infinity, especially eternity. And why was this important? Well, it was important because free will versus determinism had to do a lot with time. Okay? And I'll get to that in a second as I get into St. Thomas. What St. Thomas did, he took the ideas of Aristotle and Boethius, who both dealt with these subjects, right? He kind of studies these two fellows 700 years after Boethius, right? And he says, he applies them to free will and determinism. And you say, what does that have to do with geometry? What does it have to do with a point and with a line? I mean, I thought we were talking about points and lines here, right? Suddenly we end up with, what? With free will and determinism? Well, it's got to do with time. That's what it's got to do with. And the question was, you had this issue about the past and the future. And the question was whether God knew the future. Because if God knew the future and knew everything that was going to happen, you did not have free will. See, so this is the key point here. Now we got a big problem because I thought I had free will. I could do anything I wanted, but it turns out God already knew what I was going to do. That means the film is already there. I'm just an actor in a film that's been already made. The block universe kind of idea. Ring a bell? Okay, so this is where the issue comes into play here. And Thomas, St. Thomas Aquinas, he applied these concepts. He says there's 6 phases of free will: voluntas, consensu, intentio liberum arbitrium, usus and fructus. Okay, so if you want to have free will, you got to go through all these phases. You have to have the will, the consent, intention, free judgment, use, and enjoyment. And again, all this has to do with time. He was trying to figure out whether God knew in advance, what you were going to do, and if so, do we have free will? Okay? So this was the issue. And how does he try to justify this? Well, again, he goes to Aristotle and he goes to Euclid. He uses Euclid as well, Boethius, and he says, okay, let's see if I can figure this out. And he does an immense treatise that he writes about these subjects. Okay, and so he writes this thing. Okay. And he says, this is one of his conclusions with respect to time. He says, time is not the same thing as eternity. Okay? He says, Time and eternity are two different things. These are his conclusions. He says time you can have you can have a second, an hour, a day, and the second is part of an hour and an hour is part of a day. Okay? But there's a before a second and an after second. So it's like the second has endpoints to it. Whereas eternity, it's like it extends forever. So there's no endpoint at either end. There's always something after that because we're still going through eternity, right? And as long as you walk through eternity, you'll never find an end. And so he says these two are not the same things. Okay? And then the issue was whether these things are chopped up. Again, it comes, so he's got to start with geometry again. He brings in back the point. And he does analyze the point and the line because that's what he's talking about. He's going to apply the point to location and the line to distance, to motion, displacement. And obviously if you move, well, the clock is running, right? So you've got time in there as well. So you see how this is how this is developing, this whole thing. This eventually leads to Einstein, right? All these other people who talk about time and invented time back in the end of the 19th century, Lawrence and Fitzgerald and so on. And we'll deal with that in a little further on. But this deal with time and how geometry and the point and the line fit into this notion of time and motion and displacement and distance. This is where we're going to have a problem because the part of geometry, the point and the line, what they drew on the board, okay, that's a physical object, and that's got nothing to do with all these concepts. And you have to remember that what's happening here is that what these people are doing is that they're mixing objects with concepts, and we end up. You say, Bill, so what? Well, we got a problem because we get things like field. The field becomes a physical object when field is a concept. And you have another concept called energy, and it becomes something that, is a physical object. You transfer energy. And you have mass, and mass is a concept. How much you weigh kind of thing. And this, somehow you begin moving masses around, or the mass has the ability to move a star around. Okay, so you see where this is going. And it all starts with these fellas, okay? So that's one of the issues for Thomas Aquinas, that he's going to use this issue of eternity and whether God knows the future, whether that gives you free will. So it was an important issue for him. So he wanted to resolve that to see if he can reconcile God's omniscience with free will. That was one issue. But a more important issue, as far as I'm concerned, also you'll see where this leads, is that, and a lot of people don't know this, but Thomas Aquinas, he's the guy who discovered and invented quantum mechanics. He wrote a book on quantum mechanics. People are not even aware of that, okay? And here's a little bit of a summary, okay? I want you to see it. Okay, and this is his book, his treatise on quantum particles. And he asks these questions. These are the questions he's going to answer. He says, whether a particle is altogether incorporeal, whether a particle is composed of matter and form, whether the particles in it are in any great number, whether the particles differ in species, whether different kinds of particles, whether a particle is in a place, it has a location, occupies a location, a position, right? Whether a particle can be in several places at once, and whether several particles can be at the same time in the same place. In other words, known as superposition, okay? The other one was decoherence, right? Whether a particle passes through the intermediate space, okay? It moves, and does it pass through some point in between? And whether the movement of a particle is instantaneous. Can a particle move instantaneously? Okay? And he wrote about this in the 13th century. But the one I like the most is this other one that he's got here. Wrong one, hold it. Got the wrong one. It's this one here. Let's get it right. I lost it. I think it's this one. No, wrong one. Give me a second here. I'll get it. Oh, here it is. I just labeled it wrong. Sorry about that. This is the one that I like the most, and it goes like this. It says, whether in the angel to understand is to exist. Oh, so he wasn't talking about particles. He was talking about angels. I guess that's what he called them in those days, right? But you can see all that applies to everything that was done in the Roaring Twenties. Today we call them particles. He called them angels, but the questions are all the same. Okay? So good old Thomas Aquinas should be given a retroactive Nobel, maybe, you know, for discovering quantum mechanics. And that statement there, whether an angel, if he understands, that makes him exist, that's Descartes' I think, therefore I am. So those notions were already around, you know, for a long time. Okay, so I'm going to continue with Mr. Aquinas, especially the issues that he raises with respect to quantum mechanics. And I had one more thing here, a couple more things. This was the summary, essentially. You know, these are the foundations of mathematical physics. They have to do with points and lines, and they have to do with whether, with these issues, whether time is made of points and instants, whether motion is made of points and locations, whether locations are made of points known as numbers, whether length of time is made of points known as dots, and you know, we have the issue of space having dimensions but no surface. All these have to do, these are the foundations of physics today. They have all these issues, okay? They consider them philosophy, but this is the underlying hypothesis or assumptions of mathematical physics. They have these same issues today. Nothing has changed, and all these issues were discussed by the Greeks and by people like Aquinas. You know, all these people have dealt with these issues for a long time now. And so these are not new concepts. They've been around for a long time. They're just dismissed as philosophy. And see if I had it. Yeah, I wanted to show this. This is one of the issues that Aquinas tried to explain, and that's whether an angel can go from A to C without going through B. Can you jump over? And this is a quantum mechanics notion today, you know, where, again, you know, the angel or the particle, I guess they call them today, can jump from A to C without going through B. Can a particle be at many places at the same time? Can many particles be at one place at the same time? And so all these issues, as you can see, they've been around for a long time. All we did now is give Nobel Prizes to people whom we claim invented them, but these things have been around. And you have to give credit to Thomas here, because he did not have the benefit of accelerators. Okay, he did this all by reasoning, only by reasoning. And so in that sense, you've got to give him credit for that at least, right? Okay, so we'll see you on Wednesday. We're going to continue with some of this quantum mechanics invented by Mr. Aquinas and how they relate to the point and the line. And we're going to see that there's so many similarities between quantum mechanics and what Mr. Aquinas discovered, you know, centuries ago. And it all goes back to the Greeks, who started out at the wrong foot and built this quicksand on which mathematical physics today lays its solid foundations. We'll see you on, on Wednesday. We'll see you then. Bye-bye.